Before we get to dealing with repeated groups of data, we just want to group some variables together and give that group a name. Now, the classic old-school way is using a C-style struct. And a struct is a very basic data structure we've had in the C programming language for over 40 years, and by extension, it's also in languages like Objective-C, it's in C++, it's in C#. Now, if you haven't encountered structs before, know that I'm not using this word as an informal phrase to mean some kind of data structure. No, struct is a specific keyword in C. It is part of the language. So instead of creating these loose, informal groups of independent book variables, I could first define a book struct that contains the definition for what each book should consist of. And then I can create variables from that struct definition, in this case creating a variable called first that isn't a type of string or a type of double or bool, it's this book struct. This will now have its own self-contained set of data, its own nested set of variables, what are called member variables of that struct. So I'm using dot syntax here to let me drill down inside the struct and set the individual member variables. Now, this is about as simple a data structure as we get in any real-world programming language. It really is just a way of taking variables and packaging them together. Now, immediately, a very common question for those of you in object-oriented languages, and I'm assuming that's most of you, is, well, this kind of sounds like a class. So what's the difference between defining a struct and defining a class? Well, structs are far, far simpler. Unlike classes and objects, C-style structs have no behavior. They have no methods. They are only a container for data, simply a way to package several variables together. That's it. Also, structs don't need to be explicitly instantiated like objects do, meaning we don't use the word new or alloc or init, we just make them. Now, for those of you comfortable with the idea of references or pointers, with items being passed around either by value or by reference, structs are value types, unlike objects. They and their contents are typically allocated directly on the stack, not as a reference to some other area of memory. And of course, structs are from standard C, which isn't object-oriented. C has no classes, no inheritance, no polymorphism, so structs have none of these things. And because of all this, because of their simplicity, structs are sometimes referred to as plain old data structures or pods. But even in object-oriented languages, this idea of structs is still useful now, because there are times when all we want is a simple, bare-bones, plain old data structure. We don't need the extra weight that comes with a class. Example, if you're working with any kind of graphical element and you need a variable that represents a point on the screen, well, to hold a point is two numbers, an x and a y position. That is perfect for a struct. It will allow us to provide a formalized structure for two values. We'll call that a point type. Then we create different variables of that type. We've got some formality as to what data type they are. It lets us pass around that point variable as a single item without having constructors and methods and properties and getters and setters. Another example, perhaps to store color information. We just need a variable defined that will always hold values for red, green, blue, and alpha. Again, this kind of thing would be perfect for a simple struct definition. Now, in many languages, you already have things like points and colors predefined as data types in your provided frameworks. But even in object-oriented languages, you'll often find they are defined as structs and not as classes. In Objective-C, for example, points are predefined as structs. In the .NET languages, color is a predefined struct type. It's not a class, it's just a struct. So even in this object-oriented world, these 40-year-old data structures are still in use and still helpful. So this takes us to our first language comparison slide. What is the support like for this data structure idea, the idea of structs, across the most common programming languages? Now, a word here. Neither you nor I want this course to be a continuous laundry list of how do we do this in Python, how to do this in Java, how to do this in C++ ad nauseam, because most of that wouldn't be relevant to any one person. So when I do a comparison, it'll just be a quick summary of this data structure across a few common general-purpose languages, and I will leave the nuts and bolts of syntax and implementation details as an exercise for you, dear viewer. So, structs. We talked about their existence in C. As a few examples, while Objective-C is built directly on top of C, so structs exist exactly as in C, and they are used a lot in both the iOS and the Cocoa frameworks. In C#, and by extension in other .NET languages, structs also exist. They are simple value types, But in .NET, you can add simple methods and properties to a struct, though Microsoft do recommend if you're going to add any significant functionality, you should probably make it a class, and I quite agree. But once we get to Java, structs are not directly supported. There isn't a struct keyword. The closest equivalent in Java would probably be a simple lightweight class with no methods and only public variables, and I'll leave it to you whether that offends your object-oriented sensibilities. Now, likewise, Python doesn't have structs. There's a couple of ways to emulate that behavior, but no direct equivalent. And Ruby, structs do exist, although they are more of a simplified class rather than a pure data structure. But okay, this will do for our first language comparison. We're just kind of trying to get a feel for how this might exist and might change over different languages. Because we're done now with this level of simplistic data structure. Let's move on and start talking about collections, about having multiple repeating items, beginning with the collection we should all be reasonably familiar with, arrays.